All right, today we're going to look at something truly wild. We're talking about a crazy transformation, how a common, everyday food preservative can become a hazardous industrial chemical using some surprisingly simple low-tech methods. You got to see this.
So think about this. On one side, you've got sodium benzoate. You'll find it in stuff like sodas and jams to keep them from spoiling. Totally safe. But on the other side, benzene, a major industrial chemical, a component of crude oil, super flammable, and, oh yeah, a known carcinogen. I mean, these two things feel like they belong in completely different universes.
So that's the big question, right? How in the world do you get from a harmless preservative to a serious chemical like that? The answer, believe it or not, just involves a little bit of heat, a common base, and a process that is just shockingly straightforward.
Okay, so first things first, let's look at the ingredients. You might be expecting a long list of complicated chemicals, but honestly, the recipe for this radical change could not be simpler.
You're not going to believe this. The entire recipe is just two things: 100 grams of our starting powder, sodium benzoate, and 60 grams of sodium hydroxide, which is a really common and very strong base. That's it. Just two simple solids. That's all it takes to kick this whole thing off.
Okay, so we've got our ingredients. Now what about the prep work? Well, again, you can forget about any high-tech lab equipment. This part is all about simple physical mixing, a little elbow grease.
The process is almost comically low-tech. First, you grind the sodium benzoate into a fine powder. Then you do the same thing with the sodium hydroxide, just got to be careful with that one. And how do you mix them for maximum efficiency? You dump them into a Ziploc bag and just shake it up. Yep, you heard that right, a Ziploc bag. It's actually a surprisingly good way to get a really nice uniform mixture.
So, the chemicals are prepped and ready to go. Now it's time to build the reactor. And this is where the real backyard ingenuity shines. We are talking about a setup built from stuff you could probably find in your garage right now.
I mean, just look at this rig. It's amazing. The reaction vessel, it's just an empty paint can. The lid has a hole punched in it with a screwdriver. You jam a glass adapter in there, seal it up with some Teflon tape, and what's your heat source? A simple camping stove. It is a masterclass in scrappy DIY science.
Okay, so the mixture is in the can, the rig is all set up, and of course you take this whole operation outside for, safety reasons. Now it's time to fire up that stove and kick off the reaction. And as that paint can starts to heat up, we start to see the first signs of real chemistry happening. First, some white vapor starts to fill up the can, and then a little while later, this yellow, kind of cloudy liquid starts to condense and drip out the other end. Oh yes, something is definitely happening in there.
So what's actually going on in there? Well, it's a process called decarboxylation, which is basically a fancy way of saying you're ripping a piece off a molecule. See, sodium benzoate is just a benzene ring with this extra bit, a carboxyl group, stuck to it. The heat and the sodium hydroxide work together to violently tear off that group as carbon dioxide gas, leaving just the benzene ring behind. That benzene then boils off and gets collected.
So once the reaction peters out and there's no more liquid dripping, this is what you're left with. It's this kind of pungent, orangey-colored liquid. This is our crude benzene, but yeah, you can tell just by looking at it, it is definitely not pure yet. It's full of gunk we need to get rid of. Okay, so getting that crude stuff is one thing. But to get the real prize, it needs a good cleanup. This basically means we have to wash it to get all those impurities out and then dry it off. The purification is pretty classic chemistry, actually. You wash the crude liquid 2 times with just plain water in a special funnel. Now, benzene and water don't mix, right? So the water grabs all the gunk, settles to the bottom, and you just drain it away. After that, you dry what's left with some calcium chloride, which is just a material that soaks up any leftover water. All right, after all that work, the grinding, the reacting, the washing, it is time for the final payoff. One last distillation. This is going to separate our pure benzene from any last little bit of gunk and give us that final, beautiful product. And here is the beautiful part, the real scientific proof. As that orange liquid gets heated up again, it starts to boil. The vapor is collected, and it all happens at a super consistent temperature, 80 degrees Celsius. And guess what? That is the exact boiling point of benzene. Boom, we know for sure we've got it. And just look at that, the final result. That smelly orange liquid from before,
it's gone. And in its place is this crystal clear, colorless fluid. That right there is pure benzene, transformed from a simple white food preservative. Incredible.
What's just mind-blowing, though, is how well this whole scrappy setup actually works. From that initial 100 grams of sodium benzoate, this process gives you a yield of about 70% pure benzene. That is an incredibly high yield for something you built with a paint can in your backyard.
This whole process is it's such a powerful reminder that the world of chemistry isn't just locked away in some high-tech lab. The building blocks for some pretty potent stuff are often hiding in the most mundane, everyday materials. It really makes you look around and wonder, right? What other powerful chemicals are just hiding in plain sight all around us?